Welcome to lecture number 38 of 8051 microcontroller series. Already you know we are working on a 8051 microcontroller detailed programming and hardware and all that. In this lecture, we will be discussing on the external interrupts in 8051. Already we have seen interrupt part for timer, interrupt part for serial communication. Now it is a time to discuss on the external interrupts. Now, why we need an interrupt and what is difference between polling and all that thing, and we'll discuss in this lecture. First of all, you assume a system where there is a CPU. Okay, in any system, not only microcontroller 8051 in general, and there are number of devices outside. Those need the service of CPU. Okay, now how CPU will give the service to device actually? There are number of ways. One way is a polling way. In the polling way, what will happen in a routine, in a program of CPU, we will write some polling sequences, like CPU will ask the first device whether do you need my service, then it will ask second and third and fourth and so on. And it may happen that some device will actually needing a service, so CPU will give a service to it, and then we'll move to the next device. It may happen that somebody don't need a service, still CPU will ask. So this is just a wastage of CPU time actually. So it may happen that majority of the time CPU will ask some device whether you need a service, and the device will say I don't need a service, so unnecessary CPU will visit there. So this is a polling way. Yeah, polling way is a simple way actually for a programming perspective, but it is not recommended in real world application. If CPU don't have too much task to do to perform, or it's a very small system, then polling may help. But for big systems where number of devices are connected, and again CPU need to do other tasks as well apart from servicing the devices, so we go for a interrupt. Now, how interrupt will change the scenarios? If in that case we will activate external interrupts, it may happen that these all devices are connected to some external interrupt pin of the CPU. For 8051, we have actually only two external interrupts, but you can expand by using some chips like interrupt controller and all that. If you have studied 8085 or 8086 system, you will find a specific interrupt controller IC that we can interface with the CPU to increase the number of devices those can send an interrupt. But suppose assume that there are two pins in 8051. Actually we have only two pins, INT0 and INT1. To that INT0 INT1 we can connect two external devices. Those need a help of CPU. If that device needs a help of CPU, it will send a specific signal on that particular pin. The signal may be of two kinds. Sometimes we can have low level signal, or we can have edge, like a negative edge. Negative edge means this type of signal, and low level means that pin should remain high for a specific time. Okay, so anyway we'll discuss this low level triggered and edge triggered, all that. So a specific kind of signal CPU will send to the device will send to the CPU. So CPU will understand that device need my help, and CPU will keep whatever it is doing, some program, it will keep it aside and enter into a ISR, that is a interrupt service routine. You can say it's like a subroutine, or it's like a function. In C sense it is a function, in you can say assembly sense it's a subroutine. So CPU will perform that ISR and will come back into the whatever job it was doing, or we can say there is some main task going on, and in between that main task CPU can go into the ISR, execute the ISR and come back. Executing the ISR means giving the service to the device actually, and this is a good system because device itself will tell CPU that I need help. CPU will not waste a time asking each device that do you need my help and all that. So we can say there are no other we can say CPU is not visiting unnecessarily. Okay, we can assign the priorities, we can mask a specific interrupt. Okay, so these are all the advantages of interrupt versus the polling. In polling, as we have seen, it's a wastage. There may be unnecessary visits, priorities cannot be assigned. Okay, microcontroller cannot ignore, because it need to visit each and every device whether you need a service and all that. So it's a wastage of time. Many times unnecessary visits will be there. So this is about the interrupt. Now we'll move to the next part. Now in 8051, actually there are 6 interrupt sources. Okay, but in today's lecture, or we will be discussing on INT0, INT1. These are the external interrupts. There, you see, reset itself an external interrupt, but the task of reset is to reset the program, or you can say it's execution of program from the 000h. Okay, then program counter will show 0000h, and microcontroller will start the program executing fresh. So we cannot compare it. It's a kind of interrupt, but we'll be talking on INT0 and INT1. Already in timer chapter we discussed on timer interrupt. In serial communication also we discussed the serial interrupts. Now it is a time to discuss on INT0, INT1. Those are the external pins. Okay. So already so there are 6 interrupts, and we can, for timer 0, timer 1. For serial, there is only one, you can say, vector address 0023 for RI and TI, as we discussed in serial communication chapter. But in this chapter we'll be focusing on these two only. Okay, INT0, INT1, those are connected to the those are available on the pins P2.3 and P3.3, sorry, P3.2 and P3.3. Okay, so now we'll discuss what is ISR is. See, when interrupt comes, you can say microcontroller can finish the current instruction, whatever instruction it is doing, and it will store the program counter into stack. Why it will store the program counter in stack? Because it will be needed when it want to come back from ISR. Okay, and it will also save the status of current interrupts in some internal location and jump to a vector table, and from that it will get the vector address of the ISR. These are the addresses actually. So for a specific interrupt, and it will execute that ISR or interrupt service routine, and then it will come back when RETI instruction is there. RETI is similar to return, but RETI has some slight differences we'll discuss. So RETI is what? Returning from interrupt. So it will come back or return from the interrupt by taking whatever the program counter it has already stored in a stack memory at the time ISR was started. So it will come back in the main program from where it was interrupted. And now see, for timer 0, timer 1, you can visit my previous lectures. For serial communication also you can visit my previous lectures. So we'll be talking INT0, INT1. Okay. Now see, already we discussed in previous lecture, there is something called as interrupt enable register. Okay, by default, when we reset the system, all interrupts are disabled. We want to make them enable by making a specific bit 1 in a interrupt enable register. It's a bit addressable register, so you can write like I.7, I.0 and all that. So for now, when we want to work on an external interrupt, external interrupt 1 and external interrupt 0, not this, these two, external interrupt 1 and external interrupt 0. Okay, these two we want to discuss, EX1 and EX0. These are the specific bit. EX0 is here and EX1 is here. So we want to make these interrupts available. We should make this bit 1, this bit 1, and of course the global bit 1. See, if you don't make a global bit 1, all these bits are don't care only. Okay, so you should make this bit 1 and these two bits 1. Suppose you want external interrupt 0 available, external interrupt 1 available, you should make these two bits 1. Rest of the bits are for timer. See, this ET0 is for timer, ET1 is also for timer, ES is for serial, ET2 is not available in 8051, it is available in higher version like 8052 and all that. Anyway, so for now the important is EX1 and EX0, these two bits when we want to work with the external. Actually, external hardware interrupts, and if you are talking about the ET0, ET1, these are all internal interrupts. See, suppose I can give a very simple example. See, you are doing some study, and somebody knocks the door. So what you will do, you will finish whatever you are reading and you will just give a service to somebody. This is something a external interrupt. So it is coming from the external world. And suppose you are doing a study and you are hungry, for example. So it's like an interrupt coming from your stomach to brain, okay, and you will keep the study aside and go and eat something. This is, I can give a best example of internal interrupt. So timer, serial communication, these are all internal interrupts coming internally. But when you are talking of ex0 and ex1 associated to INT pins, these are the interrupts coming from the external world. Maybe some device connected to microcontroller which needs the service. Okay. So this is about this. Now we'll move to the next slide. Now here you can see the pins already in pin diagram chapter. We had discussed this, but I'm just repeating. So you can see these two pins, pin number 12 and pin number 13 in a port 3, INT0 and INT1. These are related to external interrupts. So where the device who needs the service, we can give a signal on these two pins. If you are not using these pins in an interrupt way, you are using them as a normal ports. Okay, it depends on your software, how you are writing on your hardware. Microcontroller will understand that these are the interrupt pin or a normal port pins. Okay. Now another important thing, INT0, INT1 can be configured in a different way, like level triggered and age triggered. Level triggered, for that actually we have to visit a TCON SFR. In TCON you will find IT0 and IT1 bits. This IT0 and IT1 bits will decide whether your external interrupt 0 and external interrupt 1 should work as a level triggered or age triggered. By default, these two bits are 0 when you reset the system. So by default, INT0 and INT1, these two are level triggered. See, level triggered means you should make that pin low for a specific duration, which depend. You need to visit a datasheet from microcontroller to microcontroller. That duration may change. For 8051, this should be you can say 4 machine cycle period. For that much period, that pin should be low. So microcontroller will understand that somebody is knocking my door or somebody needs my help, and it will enter into the ISR. Okay, if it is level triggered. In age case, what should happen? That pin should remain high and then should go low for some time. So it should be high for some time, at least minimum time, and for minimum time it should go low. This is something age positive to you can say negative age signal going from high to low is understood as an interrupt. Okay, and if you want that interrupt to be age triggered, what should you do? You should make these for interrupt 0 this bit should be 1, for interrupt 1 this bit should be 1, then and then it will be treated as a age triggered. Of course, interrupt should be active. That means in that case you should have that IE configured properly. Interrupt should be active, and then you can say these bits has some significance. Okay, now what about these two bits, IE0, IE1? These are actually in service bits. When interrupt is getting service, see, in case of interrupt is age triggered, if that age is detected and microcontroller enter into the ISR and microcontroller is giving the service, for that much time this bit will remain high. Okay, it's like a in service. So particular interrupt is getting service. Okay, and once the RETI means return from interrupt is going to executed, at that time this bit will become low. So when it is getting service, no further interrupts will be accepted. I'm talking about the these two bits are important when you are making interrupt as a age trigger. Okay, for level trigger there is no importance of these two bits, because in age triggered interrupt is not you can say when age comes it is latch in these bits. Okay, and these bits and microcontroller enter into ISR, so it is like microcontroller is giving the service. At that time this bit remain will high, and when it want to come back from ISR, automatically these bits will become low, so microcontroller will ready for next service. Okay, now in case of low level, this INT pin you can say you should remove that low signal from INT pin. See, if it is level triggered, okay, and and the level is detected and microcontroller entered into the ISR, okay, you should remove that low. Okay, otherwise what will happen, before ready, if you are not able to remove that low, what will happen, microcontroller will understand that again interrupt is coming and it will again go into the ISR. Okay, so low level signal at the INT pin must be removed before execution of the last instruction of ISR, that is ready, otherwise another interrupt will be generated. So whoever is the hardware, you can say guy, or whoever is giving interrupt should take care that it should remove that low from the INT pin. This is about the level trigger. Okay, so otherwise microcontroller will think that I am getting another interrupt. Okay, otherwise we have something we can do in the program also. I will discuss that also. So this is about, now we'll move to the next slide. We'll discuss on the program, a specific program using interrupt actually. See here, suppose this is a INT1 pin, and to this INT1 pin we have some switch here, and that switch can make that pin low for a time being. Otherwise, if you release the switch, the INT pin is connected to VCC. Okay, this is something, if you press the switch here, INT pin will momentarily get grounded, and if you remove the switch, that will again go back to VCC. So you can give this type of signal here. Okay, so this a low type of signal you can give from here, and once that signal is detected for a specific duration, microcontroller will get an interrupt. Now what I want to do, when it is interrupted, it should make a LED on. Suppose LED is connected to pin P1.3 of the port. Okay, so this is my task. If somebody press the switch, it is giving an interrupt to microcontroller, and microcontroller should make the LED on, and when it come back from ISR, it should make the LED off. So LED should remain on for a time being. If suppose that if this switch is continuously pressed up, or somebody don't remove, can say INT pin don't go back to VCC, means it is pressed for a long duration, then this LED should remain on and on, because microcontroller will get interrupt again, interrupt again, interrupt, and all that. So this type of application is this. So I have written a program in assembly language. See, org0 as usual, I'll jump main. Now see here, here is your main program. Okay, at org30, this is your main level. Okay, now we have kept this area for ISR. Now, if you see the vector table, for INT1, the address is 0030, from where you should write the interrupt service routine. Now, we'll discuss the ISR. Now, we'll discuss first of all what is happening in main program. In main program, we are making this global interrupt bit 1, and we are enabling the INT1. See, for this you can see the previous slide. In that, this bit, if it is 1, will enable the INT1. Okay, and we are not making the interrupt as a edge triggered. By default, it is a level triggered. So once this is done, microcontroller will just execute this instruction till it is getting an interrupt. See, when it will get an interrupt, if you press this switch for a, or it will, if you make this pin low for a you can say specific duration, 4 machine cycle. Now, how much should be the 4 machine cycle, that decided by the crystal. For that, you can see my previous lectures. If it is a 12 megahertz, 4 microsecond will be duration, that pin should go low. Okay. If this pin goes low, what will happen? Microcontroller will get an interrupt and will enter into the ISR, interrupt service routine. What we are doing in ISR actually, we are making this pin P1.3 as a 1, means that is what this LED will glow. Assume that this LED is connected like this. Okay, it is ground. So if you make this pin high, LED will glow. Then you are calling a delay here. See, another subroutine. See, you don't write a full-fledged program in the area of ISR actually. It is very limited space available here. If you want something big, you should write another subroutine actually. That is what I am doing here. So this will call a delay, and that delay I have some calculation here. Now how to do the calculation of delay and all that, you can see my previous lectures. And here it is a return. This return will take here, okay, with the next instruction. What we are doing here, we are clearing p1 dot 3 bit, means led will be off, and this rate will take you back in the main program. Again it will start executing as jump here, so it will stay here for long time, and if you press the switch it will go here. Okay, so when you press the switch for a specific duration, it will get an interrupt, it will execute these lines, and led will glow and for 1 second, and it will come back into the main program. This is the way this program is executing. If you want here that no further interrupt is accepted till this finishes, what you should do, you should make this bit 0 here at the start, and before return make this bit 1, this bit specifically. Okay, so what will happen so whenever the ISR is executing, it will not get interrupt again. Okay, that care we can take. I will discuss in C program. And now how to write a C program for this particular, will go into that. Okay, so here the C program is now the same. What we are doing in assembly, same thing we'll be doing here in C program. So here you can see I have given some S bits. The external interrupt 1, enable bit, global interrupt. See, this is your that bit. You can see this. This is this bit. Let me change the color of pen. See, this is this bit and this is this bit. I'm talking of IE2. IE2 is this. Okay, IE7. IE7 is this. This is a global, and this is for activating the external interrupt. So these two bit I have defined as external INT1, global INT. Then external INT age triggered bit. Okay, so this is that bit, I can say TCON2. This is TCON 0, 1, and this is TCON 2. If you make this bit 1, it will be age triggered. Now I'm not doing age trigger for timing. We'll do this in another, again I will take one more program where we'll make this bit as 1. Right now just timing, keep in mind that this is another bit. Now what is LED? LED is connected at P13, and this is a delay subroutine. Now this is a delay subroutine. At the end I have just declared that there will be some delay function, and here is the ISR. See here, I don't need to write org and all that when I'm writing in C language. The compiler will take care of that. I'm just mentioning here interrupt number. So okay, so here interrupt 2, this interrupt 2 is a keyword here. It explains that this is that interrupt. See here, this external interrupt will be taken as interrupt 0. This will be a timer related interrupt 1. This is external interrupt 1 actually. So INT 0, INT 1. So this is INT 2, interrupt number 2 here. So this is the word explains microcontroller about which interrupt this ISR is related to. Okay, then that number is taken from this interrupt enable register. Okay, so this is about the ISR, and this is your main function, right? So when execution start, microcontroller start executing from this line. So it will make global interrupt bit as a 1. That global interrupt bit is a IE7, this bit. Okay, this will be 1, and external INT1 bit, external INT1 bit is the TCON 2. Okay, so that TCON 2 will be external INT1 bit is this, sorry, IE2 bit. Okay, that IE2 bit is this bit. So we are enabling external interrupt 1. And if you want edge triggered thing, actually then you will go for global, you can say this TCON.2, that is external interrupt this bit. Okay, INT1 ET bit. We'll discuss again one more program for that. So right now we are making this bit and this bit as 1. So global should be 1 and external interrupt 1 should be active at the very beginning. Then and then it will accept the interrupt. Now while 1 means it will be just waiting here. Actually in real world there will not be this type of only while one. There will be some other program microcontroller want to execute other task, and it will be doing this task. For now, assume that this while one is the task microcontroller is doing, and when you press the pin low for at least 4 machine cycles, then interrupt will arise and microcontroller will move into this ISR. And what we are doing in ISR, we are making LED 1, that is LED on, as we discussed in assembly. Same thing is doing here. We are calling this delay function for 1 second, and again making LED 0. Now this is the delay function. This is written in C language. So it will come back from delay, make the LED off, and then it will come back to ISR and again move into the main routine, and again it will be doing this job while again you give interrupt, again the ISR will be executed. So when you give an interrupt, LED will be on for 1 second and will come back into the main program. So this is the way you can write a program in C language. See here, this is a commented line. What we can take care, if suppose you want that it should not be getting interrupted during the interrupt, you can make this bit 0, that is you are making this bit 0 for a time being, and before coming back you can write an instruction like ext int1, okay, is equal to 1 to make it active again before coming to before coming to main program. So this take care you can take if you want it should not get interrupted during interrupt. Okay, so this is the take care we can take here. And now see, same program we can write using what age triggered way as well. Only difference will be we should make this TCON.2, that this bit IT1 bit as a high in a main program. So that program I have also written here. So here it is, that program. Now what I am doing here, yes, global interrupt bit is 1, then this I bit for INT1 is also 1, and this bit is 1. This bit 1 makes what? It makes this IT1 bit that is TCON.3 bit, okay, see that sorry, TCON.2 bit as this bit as a 1. So it makes that interrupt as a age trigger. So it will accept this type of signal and get interrupted. Rest of the thing will remain the same. I am not changing anything, only making the interrupt age triggered. We have to do this at the very beginning in the main program. Now one more thing I need to discuss about the in-service bits. Already I discussed that in-service bits are I0 and I1. These bits will be high when age triggered interrupt is detected and will remain high till return executes. So rather return from interrupt executes. Okay, so it will be automatically cleared. Okay, when these bits 1 means microcontroller is not ready to accept again an interrupt on that pin till that interrupt gets serviced. Okay, so it will not get interrupt in an interrupt. So this is what something about the age trigger. So already we discussed this, so you can read this. And yeah, and for age triggered this should be the requirement that the pin should be high for at least 1 machine cycle and should go low for 1 machine cycle to accept that interrupt from microcontroller. In this calculation I have shown for a XTAL 11.0592 megahertz. For 12 megahertz it will be 1 microsecond, 1 microsecond. And one more thing I need to add here is this thing. One more thing, yeah, for active low it should be high for 1 machine cycle and it should go at least for 4 machine cycle low for interrupt to be accepted. So these are what the data sheets you can refer for different microcontrollers. This is for low level trigger. Anyway, I think you must have understood the interrupt, which is very important topic. We'll come to this topic in the next lectures, where we'll be doing a real-time projects. Maybe suppose I am doing a project on a smoke detector. Okay, so smoke detector will when the signal you can say sensor detects a smoke, it will give an interrupt. Okay, and microcontroller will go into the ISR and may send an SMS to somebody using you can say serial communication and using you can say modem, GSM modem and all that. So that type of project can be done. So in ISR, what microcontroller will be doing? It will be sending an SMS that smoke has been detected. Okay, so this can be a very can say simple application to understand this. So thanks for watching.